Hi everyone, welcome to talk session. Let's continue with few more examples on designing of DFA. Here question is design DFA that accept all strings where length of the string should be divisible by 3. First try to identify and understand the condition here. What's the condition? Here length of the string should be divisible by 3. So first write down the numbers divisible by 3. If any number is divisible by 3, it means what? If that number divided by 3, we should get the remainder 0. So if 3 divided by 3, we are getting remainder 0. If I write here 4, is this number divisible by 3? No, because if 4 divided by 3, we are not getting remainder as 0. So 4 is not divisible by 3. So I won't write here 4. Next number will be 6. Next will be 9. Because when these numbers are divided by 3, we are getting remainder 0. Also we have 0 also. If 0 divided by 3, then we are getting remainder 0 only. Hence 0 is also number which is divisible by 3. This is the part of mathematics and you might be aware of this. Now try to write down the minimum length string as per the given condition. Condition says that string length should be divisible by 3 and we have already written the numbers which are divisible by 3. 0, 3, 6, 9. So what is the string whose length is 0? We know epsilon. Epsilon is the empty string whose length is 0. What are the strings whose length is 3? We have sigma given. Always check sigma. Sigma contains a comma b. In another question, sigma may contain 0 or 1. So based on the sigma, write down any string whose length is 3. So length 3 means what? There will be any 3 symbols. It may be triple A, it may be triple B, or any combination of A and B. Only thing is that length should be 3. Similarly, we can write down the string whose length is 6. For example, triple A, triple B, or any combination of A and B. No need to write all these strings. Once we understand the condition, we can design DFA accordingly. So start designing DFA for this question. As we know, automata consist of various states and states are represented by circle. First state is Q0. As epsilon is a part of minimum length string and as I explained in my previous videos, whenever epsilon is a part of MLS, your starting state becomes final state. Hence Q0 is a final. Epsilon gets accepted now. Next valid string is AAA. AAA should get accepted. It means what? After reading this AAA, automata should reach out to final state. So start designing automata for the AAA. First symbol is A. One state read one symbol at a time. So Q0 will be reading the first symbol A. Q0 reading the first symbol A. Only one length string should not get accepted, so it will go to the non-final state. Second symbol is A. Q1 should read second symbol. Two length strings should not get accepted, hence transition for the second A should reach out to the non-final. Third symbol is A. Transition for this third symbol A should reach out to final state because the length of the string becomes 3. So transition from Q2 for the third symbol A should go to the final state, but already we have the final state. So I can write transition like this. So transition from Q2 for the third symbol A going to state Q0 as a final state. There might be question in your mind why we are connecting transition from Q2 to Q0, why we are not creating the new final state. Reason behind this, we can utilize the existing final state. Hence we are connecting transition from Q2 for third symbol to Q0 unless and until it's not reading any invalid string. And always remember, our automata should always contain minimum number of states. Now we design DFA for 3 A's or string having length 3. This is for A. If I take the next valid string triple B, or we can take any combination of A and B. First symbol is B. First state will be reading the first B. Already we have transition for existing single symbol A. I can write down here A or B. How to read this? Q0 reading single A or B. Second symbol is B. Automata is at the state Q1. Q1 will be reading B also. I can write here A or B. Automata is in the state Q2. Third symbol is B. So Q2 will be reading third symbol. There is already one transition. I can write here A or B. So transition from Q2 will be reaching to Q0 and I can read like this. Q2 is reading A or Q2 is reading B. So automata is in the state Q0. Triple B gets accepted. as automata is in the final state. If I want to check for ABA, automata starts with the symbol A, starting state Q0, Q0 reading the first A, going to state Q1, Q1 reading the second symbol B, automata goes to state Q2, Q2 reading the third symbol A, automata goes to state Q0, Q0 is a final state, hence ABA is accepted. As by reading ABA, automata is reaching to final state, hence ABA is accepted. As I mentioned previously also, always check whether automata is deterministic or not. What is deterministic? There must be only one transition for each symbol of sigma. Here sigma contains A comma B. So from Q0 there must be transition for A as well as for B. Here we have transition for A and B from Q0. Similarly we have transition for A and B from Q1. Similarly we have transition for A and B from Q2. Hence all states are deterministic, hence I can say this is deterministic finite automata, and this is final answer to our question. You can practice similar kind of question where length of the string should be divisible by 3 but sigma is here 0, 1. In the next session we will be learning how to design automata where length of the string should be divisible by 5. Thank you for watching.